3I-Atlas is unlike anything we have ever seen before. Discovered on July 1st, this interstellar visitor is racing through the solar system at an incredible speed of 210,000 km/h. But that's not the most exciting thing about it. The object is also exhibiting behavior that amazes even experienced astronomers. Its light seems to come directly from its surface rather than from its gas and dust envelope, as is typical for comets, as if it had its own light source. But then something else happened that has never been observed in comets before. 3I-Atlas suddenly changed color from red to green while its brightness fluctuated dramatically. But what is causing this strange spectacle? Could it be a completely unknown cosmic phenomenon? Or is our guest ultimately much more than a natural chunk of rock? Stay tuned until the end and find out with us. Since its discovery in the summer, 3I-Atlas has continued to surprise the research world. During the first observations, it was already noticeable that its coma is unusually thin and irregularly structured, quite different from ordinary comets, which usually have a dense, uniform gas and dust envelope. No less astonishing is its broad, diffused tail, reminiscent of a kind of cosmic flag. But that's just the beginning. Normally, comets follow a predictable brightness curve caused by the heating of their ice near the sun. However, 3I-Atlas turns this common pattern on its head. Its brightness flickers in sudden, irregular jumps, sometimes increasing and then decreasing again, which, to put it mildly, is somewhat surprising for a comet. And then there's also the color change. The object suddenly changed from red to green, exhibiting behavior that is virtually unheard of in comets. Combined with the brightness fluctuations, researchers are faced with a challenging puzzle. But what could it be? Well, basically, the green color of comets is caused by dicarbon molecules that fuse when they evaporate. However, dicarbon was practically undetectable in 3I-Atlas. Instead, observations by the James Webb Telescope showed increased amounts of carbon dioxide, nickel, and cyanogen. However, these substances are not actually responsible for the green glow, and that naturally raises questions. So, what is causing our interstellar visitor to shimmer green? Is it an unknown gas? Or, as some daring researchers speculate, the result of an undiscovered energy source? What is certain is that 3I-Atlas has some exciting mysteries in store. And as mentioned, these include its unexpected brightness fluctuations. Experts explain these sudden fluctuations by the rapid evaporation of volatile substances on or near the surface as a comet approaches the sun. When such a chunk is heated up quickly, it can release enormous amounts of gas and dust and greatly increase its brightness within a few hours to a few days. This phenomenon is called an outburst, and we have already observed it in several comets. However, such a process does not always leave a comet unscathed. If the release of gas and dust becomes too intense, it can exert pressure on the nucleus. Once this becomes unstable, it can break up into large fragments such as Comet Shoemaker-Levy 9, which broke into several pieces in 1994 before crashing into Jupiter. Alternatively, a slightly different explanation is also being discussed. What if the brightness and color displays of 3I-Atlas have less to do with gas and dust and more to do with a mothership sending research probes into the solar system? Is 3I-Atlas more than just a comet? If you think this is just a crude theory floating around in some semi-serious forum, think again. In fact, this approach comes from none other than A.V.I. Lowe, an astronomer who works at the renowned Harvard University. But what leads Lowe to this wildly unconventional assumption? Well, he bases his theory on several observations. First, there is the unusual brightness of the object, which according to Lowe is difficult to explain by sunlight and normal comet activity. Instead, he speculates that 3I-Atlas could generate its own light, possibly through some kind of nuclear energy source. Furthermore, the astonishing precision of its trajectory would also give the impression that the object is deliberately navigating through the solar system in order to pass through very specific areas. More specifically, this refers to the fact that 3I-Atlas comes suspiciously close to planets such as Venus, Mars, and Jupiter. And according to a study by Lowe and his colleagues, the probability of this being a mere coincidence is less than 0.005%. Against this backdrop, it could be that the interstellar visitor is not actually a natural chunk of rock at all, but an extraterrestrial spacecraft sending small research probes into the solar system. Conversely, The released spacecraft would also be responsible for the sudden bursts of brightness, but caution is advised. Before you get the impression that Lowe is an enthusiastic alien advocate, we need to put his statements into proper context. He himself explicitly emphasizes that the most likely explanation for 3I-Atlas is still a natural comet. But then what is all the speculation about an extraterrestrial mothership? Well, essentially Lowe is concerned with questioning the obvious. In other words, science should not automatically interpret everything as natural just because it fits into the known category so far. Just because something is extremely unlikely does not mean that it should be completely ruled out. Lowe's approach is to seriously discuss all possible explanations so that unknown phenomena are not overlooked. Objects such as 3I-Atlas's interstellar predecessor Oumuamua have already shown us that surprises are possible. And it's precisely this way of thinking that should stimulate new observations and discussions. When a comet breaks the rules. Avebe even floated the idea that the sudden discovery of comet CL 2025 F2 Swan could be a fragment or probe released by 3I-Atlas near Mars. However, subsequent investigations showed that the comet originated from the opposite direction. Nevertheless, Lowe warns that we should not underestimate the unusual nature of this interstellar visitor, because during its close passage to Mars on October 3rd, the object could still exhibit changes that we do not see in normal comets. The bottom line, however, is that not only the behavior, but also the origin of 3I-Atlas is remarkable. Even though we cannot say where its exact origin lies, the object entered our home world from the constellation Sagittarius. According to Loeb, this is remarkable because mysterious radio signals have been detected from that direction for decades. Most notably, the famous WOW signal in 1977, received by the Big Ear radio telescope at Ohio State University. This signal was not only exceptionally strong, but also exhibited characteristics that could indicate an artificial origin. However, it's uncertain whether this was really an alien message, primarily because it was only detected once. But if we turn our attention back to 3I-Atlas, we see that the object not only comes from a very specific direction, but also follows a no less specific trajectory that runs almost parallel to the plane of the solar system. As mentioned, the interstellar visitor comes very close to some planets. But curiously enough, it gives Earth a wide berth. But that's not all. At its perihelion, or in other words, the point closest to the Sun, 3I-Atlas will also disappear behind our host star. As a result, it could continue its activities far away from our curious gaze. Well, assuming it really is artificial, of course. But once again, let's remember that the vast majority of researchers remain convinced that we are dealing with a purely natural guess here. Even if it does like to break the usual rules, its astonishing properties, such as its surface, which appears to glow on its own, or its sudden color changes, make 3I-Atlas one of the most fascinating objects ever observed in space. But aside from all the spaceship theories, we should not forget that this chunk of matter also has outstanding potential for conventional science. 3I-Atlas most likely originates from a very old region of the Milky Way, and that is precisely what makes it so exciting for experts. It's estimated to be over 7 billion years old, and carries information from the early phase of the galaxy. Its composition can tell us how stars and planetary systems were born billions of years ago, and how matter can be transported over vast distances between different star systems. The latter even touches on the exciting theory of panspermia, which is based on the idea that the building blocks of life or life itself came to us from the depths of space in the first place. Experts therefore plan to take a close look at 3I-Atlas during its close passage by Mars. On October 3rd, the comet will pass the red planet at a distance of only about 30 million kilometers. And NASA wants to take advantage of this unique opportunity to point the high-rise camera on board the Mars Reconnaissance Orbiter at the object. This will allow the brightness of the core and the dust shell to be analyzed separately, which is crucial to finding out whether the chunk actually generates its own light. The ESA's JUICE mission could also contribute further data at the end of the year, as could NASA's Psyche mission. If everything goes according to plan, this will be the first time that an interstellar object has been studied in detail from close proximity to another planet, and it would open a unique window onto one of the most exciting objects in current space research. And one click on the subscribe button opens a window to our new videos. Become part of our community now to stay up to date from now on. See you soon.